Hi guys, this is Akash from BreVITy, and today we'll be looking at another Leetcode based problem. It's called as sliding window maximum. It's kind of a hard problem. So let's look at the problem statement now. You are given an array of integers nums. There is a sliding window of size k which is moving from the very left of the array to the very right. You can only see the k numbers in the window. Each time the sliding window moves right by one position. Return the max sliding window. Okay, so what we are given with is an array called as nums, and we are also given an integer k which denotes the length of the sliding window. So what you're supposed to do is we are supposed to have a sliding window of size k which starts from the very left of the array. So our first sliding window would be this, and this sliding window moves to the right by one position each time. So what you're supposed to do is in each of these sliding windows we are supposed to pick the maximum element in that window and put it in an array called as the output array. So in the first window over here, the maximum element would be 3. So 3 is put in the output and our sliding window moves to the right by 1. So this is the next window. And again 3 is the maximum over here. So 3 is again put in the output. And this is the next sliding window. So in this one, 5 is the highest. So 5 is put over here. So on and so forth until the last sliding window, which is this. So this is what the problem says. Now let's look at our approach and how we are going to solve this problem. To solve this problem, we'll be making use of a data structure called as a DQ. A DQ is also known as a double-ended queue, and it is available in the C++ standard template library, also Java collections framework. So the DQ allows us to have push and pop operations at both ends of the queue. So we'll be able to push and pop elements from the front, and we'll also be able to push and pop elements from the back of the queue. Hence the reason why we're using a DQ. So now let's look at the algorithm. So what happens is we'll be running a for loop from 0 to the very end of the array, and each time the element that is being considered will be a part of the current sliding window. So now what we do is we keep pushing elements at the back of the DQ. The main idea is to maintain the maximum element of the current window at the very front of the DQ. So for a window, the maximum element of that window will always be at the front of the window. So we can access the maximum element by looking at the front element in the DQ. And if the element at the front is not a part of the current window, we pop it out because we cannot no longer use that element in our further sliding windows. The new element being added to the window, if it is greater than the element which is at the back of the sliding window, what it means is the element at the back is no longer a maximum element because we have a number which is greater than it, which is coming in newly. So we'll have to remove that element which is present at the back and make way for the new element which is coming in. So until the element at the back becomes greater than the element which is coming in, or the queue becomes empty, we keep popping out from the back. So these are the 3 steps to our algorithm. Now let's look at a dry run and an example for this. Okay, so this is the nums array that we are given with 1, 3, minus 1, minus 3, 5, 3, 6 and 7. And the size of our sliding window is k is equal to 3. So this is our DQ, and our DQ will have a maximum of 3 elements. And this is where our output elements will be inserted. And our I pointer, it starts from 0 and it goes to the very end of the array. So let's look at the dry run now. So initially I points to 0, and our first sliding window would be from 0 to 2. Indices 0 to 2. So it would be 1, 3 and minus 1. So initially I points to 0, and since the queue is empty, we'll just push 0 onto the DQ. Now we move our I pointer towards the next element. Now I is at index 1 and it points to the element 3. Now what you need to do is compare this 3 with the element present at the back of the DQ, which is 0. which means nums of 0, which is 1. So this one is obviously smaller than this 3, and therefore it cannot be the maximum of this sliding window or any sliding window which comes after it. So this one is no longer helpful for us or needed by us. So we just need to pop that index 0 out from there. So we pop index 0 out. At this point our DQ now becomes empty, and so we push index 1 onto our DQ. Now we move our pointer to the next element. Now it points to index 2, and the element at index 2 is -1. So -1 is not greater than 3, so we just push -1 onto our DQ and continue. So at this point, we have looked at all the elements in our first sliding window, and we will have the maximum of this first sliding window at the very front of our DQ. So the element at the front is 1. So we look at index 1. So index 1 has element 3. So now we need to push this 3 onto our output, because that is the maximum of this sliding window. So 3 is now pushed on to the output array, and now we move our pointer to the next element. Now our sliding window becomes 3, -1 and -3. Now -3 is smaller than the element at the back of the DQ, which is -1. So we just push index 3 onto our DQ. At this point, we now have looked at all elements belonging to this sliding window, and the maximum will again be at the front of the DQ. So the maximum again is index 1, element at index 1, so it is 3. So now we push 3 onto our output array. Now we move our eye pointer towards the next element. At this point, our sliding window becomes -1, -3 and 5. If you look at it, this index 1 is now no longer part of our sliding window. So we'll need to pop that element out. So we pop out element 1, index 1. Now we need to check if the current element, which is 5, is greater than the elements at the back. So the element at the back is index 3. So index 3 points to element -3. So obviously 5 is greater than -3. So what we conclude is -3 can no longer be a maximum of this sliding window. So we pop out -3 from our DQ. Now our back is 2. So the element at index 2 is -1. Again, -1 is smaller than 5. So -1 can no longer be the maximum. So we pop out -1 also. At this point our DQ becomes empty. So we just push index 4 onto our DQ. Now we have looked at all elements belonging to this DQ and the maximum to this sliding window, and the maximum will be at the front of the DQ. So the maximum is present at index 4. So index 4 value is 5. So we push 5 onto our output array. Now we move the pointer to the next element. Now it points to 3. So 3 is smaller than 5. So we just push 3 onto our DQ, the index 5 onto our DQ. Now we have looked at all the elements present in this sliding window. So the maximum is present at the front of the DQ, which is present at index 4, which is again 5. So we push 5 onto our output array. Now I is incremented. Now it points to element 6. So 6 is greater than the element at the back of the DQ, which is index 5, which is 3. So this 3 will no longer be maximum of this sliding window. So we'll need to pop that 3 out. So we pop it out. Now the element at back is at present at index 4, which is 5. So again 5 is smaller than 6. So 5 cannot be a maximum. So we pop out 5. Now our DQ is empty again, so we push the index 6 onto our DQ. At this point we have looked at all the elements of this sliding window, and the maximum will be present at the front of the DQ, which is present at index 6 and also element 6. So we push 6 onto our output array. Now the I pointer is incremented. Now it points to element 7. So The element at the back of the DQ is 6. 6 is smaller than 7, so we'll need to pop 6 out. So 6 is now popped out. At this point our DQ becomes empty, so we'll push this index 7 onto our DQ. And now we have looked at all the elements present in this sliding window. So we push the maximum which is present at index 7, which is the element 7, onto our output array. At this point there are no more sliding windows which we need to discover. So at this point we can stop our for loop, and this is the final output array that we have. So now we return this output array. So this is what the basic problem is. We make use of a DQ, we push in elements at the back, and the maximum is always maintained at the front. Now let's look at the code for it. So as usual, step 1 in solving a problem is implementation. So let's initialize our DQ first. DQ int q1. Let's also initialize our vector, which is going to be our output. So vector int, let's call it output. Now we run a for loop for I int I is equal to 0 till I is less than num start size I plus plus. Now inside this for loop we need to check for two things. The first thing is we need to check if the element present at the front of the DQ belongs to the current sliding window or not. So to do that we need to check this. So if not of q1 sorry not of q1 dot empty. So we need to check first if our queue is empty or not, because if our queue is empty and we try to access the front element, it will throw us an error. Next we need to check if q1 dot front is less than equal to I minus k. Now why I minus k? Let's take this example. Let's consider this sliding window 3, minus 1 and minus 3, and let's say that this one is still a part of our DQ. So this is index 0 over here, and now our I would be pointed to index 3. So the elements that belong to this sliding window would be 1, 2 and 3. So anything less than I minus k, which is 0, so anything less than or equal to 0 will not be a part of this sliding window. So we'll have to remove that from our queue. So that's why the condition I minus k. So q1 dot pop front. Next we need to check if the element at the back of the DQ is smaller than the element which is coming in. Because if the element at the back is smaller, it will no longer be the maximum for that sliding window or for any sliding window hereafter, because there is an element which comes after it which is greater than it. So we need to remove those one too. Again we'll have to check if our queue is empty first. Out of queue dot empty and nums of q1 dot back less than equal to nums of I. So in this case we pop from the back. So after we have done these two things, now we can safely add our current element onto our DQ. So q1 dot pushback of I. Now we need to check if we can add the element at the front of our DQ to our output array. To do this, we'll also have to check one more thing. We need to check first if we have all the elements of at least one sliding window. If we take an example, first I points at 0. So at this point we cannot add this 0th element or 1 onto our output array because there are still two more elements which we need to look at. So then we look at 3 and then we look at minus 1. After looking at minus 1, can only we push the element at the front of the queue onto our output array, because until then we will not have explored all the elements of the current window. So to check this we need another if condition. So if I is greater than or equal to k minus 1. So k minus 1 here would be 2. So when I is greater than or equal to 2, so that means we'll have seen the first three elements Only in that case can we push the element in the front of the DQ onto our output array. So output dot push back nums of q1 dot front. So this is it for inside the while for loop, and outside the for loop we now need to return our output vector. So this is it for the code. Let's run it and see. Okay, submit the code. Okay, so our code has passed all the given test cases. So that is it for this problem. Now let's look at the time and space complexity. Now if you look at the time complexity, all the elements in nums array are being pushed on to the DQ at most one time, and they're also being popped out from the DQ at most one time. So each element is seen at a maximum two times. So our time complexity would be O of 2n, but O of 2n is, as we know, is just O of n. So our time complexity is O of n. And as for our space complexity, we are using extra space as our DQ over here, and our DQ at any given time will contain a maximum of k elements. So our space complexity would be O of k. So that's it for this video. So if you understood this problem, please do like this video and subscribe to our channel. This is Akash signing off until next time.